Okay, for 10.5, recursion and iteration. What we're going to focus on this time in this video is just the recursion part of this lesson. Okay, so recursion, what that means, real quick, is this. Up until this point, you guys, we've been dealing with explicit formulas where nothing's dependent on any previous term. Okay, we're just like using rules. Today is very similar. We are going to use rules, but the recursive formula is always dependent on the previous term. And how the previous term is identified typically is like this. So instead of saying previous term, they're going to use this terminology, which means take so a sub n is just some unknown term, right? But then we're going to take that unknown term and we're going to subtract 1. That means, this means previous term when you see it today. Okay, so whenever you see that, it means previous term. If you see this terminology, this means the next term. So, for instance, if I wanted to find, for instance, a sub 3, like the third term in a sequence, then what I would be doing is I would be substituting a 2 in for n. Okay, and you'll see where this comes in handy in order to find a sub 3, because 2 plus 1 is 3. Anyway, these are a couple things. This just means, so this one here means next term, right? The next term in the sequence. And if you subtract 1, you're talking about the previous term. Okay, so 2 formulas to know. One is the arithmetic formula, which basically states that we're going to take the previous term and then we're going to add the common difference. All right, and then another one would be the geometric sequence where we take the common ratio, right? The thing that's being multiplied each time. We're going to take that and multiply it by the previous term to find the next term of the sequence. Okay, so let's see what this looks like. And for today, you guys, I'm only going to focus on using formulas. So that's example 1. And then I really want to focus on example 3, which is, we'll get there in a second, but this talking about like how do I find how much I owe on a bill that's accumulating interest over time, because that's built on a recursive type of formula. And I think it's very practical. So example 1 says find the first 5 terms of the sequence in which a1 equals 8 and a sub n plus 1, which means the next term, is equal to negative 3 times an plus 6. All right, so let me show you how this looks. We know the first term is 8. Okay, so it says to find the first 5 terms, so we need the next 4 because they've given us the first one. So we're looking for these guys. Okay, we're going to use this pattern. So if I plug a 1 in right now into this formula, notice what happens. I get a to the 1 plus 1, which is a2, right? Which is this just means second term. Second term will be equal to negative 3 times a sub n, which again, I'm going to plug in a 1 for n, right? So this would be a1 plus 6. All right, so now I'm just simplifying this out now. This is saying the second term is equal to negative 3 times the first term. Well, I know what a1 is. They gave me a1, right? So I'm going to plug it in. Negative 3 times 8 plus 6. Okay, so when I do that, I get negative 24 plus 6, right? Which is, what, negative 18? So the next term in the sequence is going to be negative 18. Okay, to find the third term, I'm going to have to plug in a 2 for n, because again, these things are built on the previous term. So now what I can do is, or you could use this again, which maybe I should show that. We're essentially taking the previous term, multiplying it by 3, negative 3, and then adding 6, right? So I could do that here again. So I could just take negative 3 times the previous term, right, and then add 6. So here in this case, negative 3 times negative 18, if you do 3 times 18 there, you get 54, so that's positive, right, because negative times a negative. And then you add 6, you get 60. So the next term would be 60. Then you would plug that in. So negative 3 times 60 plus 6. Okay, so negative 3 times 60 is negative 180 plus 6, which is equal to negative 174. Okay, then you would plug that one in. So I'll let you guys come up with that one. All right, but it would be negative 3 times negative 174 plus 6. Okay, and when you do that out, you should get 528. All right, so that's example 1. I want you to be comfortable doing that, just using a recursive formula, and these will show up in different ways. But just know that a sub n, you can plug in whatever you want for n. So if typically you're going to have you looking for the first 5 terms, and you're always going to be plugging in a number that will give you the next term. Okay, so be very careful to what's going on there, because sometimes they might give you something like a sub n plus 2. So if they do that and you plug a 1 in, you're going to be finding the third term, which means they probably already have given you the first 2 terms and they're looking for the next 5 or something like that. So just be mindful of what this stuff means when you're plugging numbers into these equations. Okay, so that's example 1. I was going to have you guys write these recursive formulas, but I think I'm not. I'm going to skip over that for now, because you will write one for this, and I think this is much more meaningful. Okay, so for example 3, you're going to use a recursive formula to figure out the next payment on a debt. Okay, so think about this. If you have to pay on a debt, you're always going to have your debt amount. So in this case, the debt amount's $10,000, right? Okay, then interest is going to be applied. So in this case, the interest is going to be 2.5%. So in order to figure out what that would be, we would take 1.025, right? 1.025 is just the same thing as taking the whole principal 10,000 multiplied by 2.5% and then adding it back in, right? So if I take this guy times 1.025, that'll tell me what my new balance is. Okay, but then we're also paying $600 a month, right? So subtract 600. So what they want us to do is they want us to write a recursive formula for this, and then they want us to find the first 5 balances, right? Okay, so to find the recursive formula, basically what I would do is I would drop this piece out because I want to be able to use this formula for anything, right? So it would be 1.025 times the previous term. The previous term is a sub n minus 1. Okay, so we're going to multiply 1.025 by the previous term, and then we're going to subtract 600. That is my nth term formula. Okay, so that's the recursive formula that they want to use. Okay, they want us to use. So now I can just plug in 10,000 to this to figure out what my next one is. So my first balance is 10,000, right? Plug a 10,000 in, and take 10,000 times 1.025, subtract 600, and my next one will be 9,650. Then I'm going to plug that thing in to my recursive formula. So 1.025 times 9650 minus 600, and I should get 9291.25. Okay, then you plug that one in to this formula, right? And you end up with 8923.53, and then you plug that thing in, and you should get 8546.62. I don't know why I wrote a 4 there. Okay, so those are the 2 examples that I wanted you guys to see. Homework will be related to examples 1 and 3, and we'll talk about any questions you might have next time in class.